امم Hi everyone, am I audible? Is the audio clear? Let me know. Okay. If there is any issue, you let me know. Okay. So today we will start discrete mathematics revision course. Okay. So in this course, I'm not going to teach you some concept in detail. Okay. So we will not see the details of any concept. Okay. But I will give you some overview of any concept that we are going to see. So basically we will take gate exam questions and many more questions we will see. Okay, so some standard university questions also I have taken. Okay, so all these questions we will solve. Okay, and for every gate exam question we will do the complete analysis. Okay, so like all the variations and everything. Okay, so what are the possible variations for that gate exam question? So this is our motto. Okay, so let me introduce you. So my name is Deepak Punia, and I'm your discrete mathematics faculty for today. Okay, so I have done my MTech from ISC Bangalore. Okay, and basically now you can see, so I am discrete mathematics faculty in Go classes. Okay, so let's start. So basically the lecture is all about discrete mathematics revision. Okay, so discrete mathematics revision. Today what we are going to take, basically we are going to see the combinatorics. Okay, so this combinatorics questions we will take and set theory. Okay, so if there is time, okay, then we can also see. So maybe tomorrow we will see first order logic, and you can see group theory and graph theory. Okay, so main topics for today, these are the topics: combinatorics and set theory. Okay, so let's start. So first we will start with the combinatorics. Okay, and in the combinatorics, the first thing that we should study is the sum rule. Okay, I hope you already know what is the sum rule. Okay, so these PPT you don't have to write. Okay, just focus and just understand everything. You don't have to write anything because these annotated notes I will provide. Okay, so you can access these annotated notes from the Go Classes website. On the Go Classes website there is a revision course. Okay, and that course is accessible to everyone. Okay, so if you go to Go Classes, okay, so on this Go Classes website you can see there is a revision course. Okay, so in this revision course actually you can access these videos. Okay, and these PPTs annotated. Okay, so basically you don't have to write. Okay, just focus and just understand everything. That's the point. Okay, because I'm going to touch every topic of combinatorics, I'm going to touch every topic of set theory. Okay, so that is the target. Okay, so what is the sum rule? Let me just quickly revise. Okay, so this is the most simple rule, sum rule. Okay, it basically says that if you have two tasks, okay, you want to do a task T. Okay, so this is your task T, and if you want to do this task, so this is our main task that we want to do, but either you can do task T1 or you can do task T2. Okay, and so let us assume how many ways are there. So this is the question: how many number of ways to do task T. Okay, to do T. So how many ways are there to do this task? So that is the question. Okay, so the answer will be number of ways to do this task T1. Okay, so let's assume there are n1 ways to do this task T1. There are n2 ways to do this task T2. Okay, and there is one more important, very 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 important condition, that is these n1 ways must be completely disjoint from these n2 ways. So that is the important thing here. Okay, so this is very important point that I want to stress. Okay, so the here these must be disjoint. Okay, basically this task and this task, they should not have any common way of completion. Okay, you should not have any common way of doing this and this. Okay, so they must be completely different ways. So these n1 ways and these n2 ways, they must be completely disjoint. Okay, so these are basically disjoint. Okay, so these n1 ways and these n2 ways, they must be completely disjoint, completely disjoint. Okay, so if this is the situation, if these three, if these are the, if these situations you have, then answer will be number of ways to do task T, that will be n1 plus n2. Okay, so this is your summation rule. Now on the summation rule, actually basically this is the very important point that many students will miss out. This is the very important point. Okay, so these and these, they must be completely disjoint. You should not have a same way, like there should not be any common way of doing t1 and t2 simultaneously. Okay, so let's see this question. Can anyone try? What is the answer? Can anyone try this question? If we roll two dice, one green, one purple, so the dice are basically different. How many ways are there to get a sum of 7 or 11? So this is your task. Your task is to get a sum of, basically this is your task. Okay, sum is equal to 7 or 11. This is your main task. Okay, so this is your task T. Now, okay, to do this task, what you can do, either you can get a 7 or you can get a 11. Okay, either you can get a 7 or you can get a 11. And you can anyone tell me, is it possible that you can get 7 comma 11 at the same time? Like, is there any common way of doing so? Okay, is there anything, like, is there any way we can do this task and this task simultaneously? We can complete both of these simultaneously. Can we do so? No, we cannot do, because if we are getting 7, then we cannot get 11. If we are getting 11, we cannot get 7. So this condition is satisfied. This disjoint condition is satisfied. Okay, so you can notice this is the point. Now, how many ways? So number of ways to get a 7, what is that? And number of ways to get 11, what is that? So number of ways to get 7, what is that? So very simple, because you have, okay, so let's see. Number of ways to get 7, you have green dice and you have purple dice. Okay, so you have dice, okay, and you have another dice. So you can notice, if you want to get 7, then okay, so this plus this should be equal to 7. So what you can, okay, you can have this. Okay, you can have this, you can have this, and okay, so 4 3, and you can notice, okay, 5 2, and you can notice 6 1. Okay, so these are the ways. Okay, so total 6 ways to get 7, to get sum of 7. Okay, and similarly, how many ways to get a sum of 11? How many ways do we have to get a sum of 11? So you can very easily calculate, okay, how many ways we have to get a sum of 11. So let's just see. Okay, so to get, okay, if you have basically, okay, you cannot have this, because if you have 1, then you can never get. Okay, if you have 2, you can never get. If you have 3, you can never get. Okay, so the what are the only possibility? The only possibility is actually, okay, if you have 5 here, 6 here, 6 here, 5 here, this is the only possibility. So only 2 ways to get a sum of 11. So here you have 2 ways. Okay, so I can say here number of ways is 6, here number of ways is 2, and the final answer will be here, the final answer will be 6 plus 2, that is your 8 ways. Correct? Okay, yes or no? So this is your summation rule. This is a very basic rule. Okay, and this is what you need to take care. Again, I am telling you, this is the first thing you need to take care today. Okay, so let me just write it here. Okay, this is very 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 important. Okay, so these n1 ways and these n2 ways must be completely disjoint. Okay, so there should be no common way of doing t1 and t2. Basically, in this summation rule, let me write in this summation rule, there, okay, no, okay, there should be, so here I can say basically there should be no common way of doing t1 comma t2 together simultaneously, or I can say, okay, there should be no common way. Okay, anyway, this is the first thing. Now let's see what is the product rule. And the product rule is also very simple, but the product rule has many applications actually. Okay, so first of all, what is the product rule? And here you have to take care, because this is my favorite rule actually. Many questions you can solve using product rule only. Okay, so in our Go classes also, every, I think, I think most of the concepts we have proven using the product rule. Okay, many questions we have solved using the product rule. This is my personal opinion, that if you are very good with the product rule, then basically combinatorics is very easy for you. Okay, so this product rule is very important. Okay, all the concepts, permutation, combination, okay, many concepts that you study, okay, like permutation, combination, and etc. Okay, so the distribution questions, okay, so all these can be proven using the product rule. That is the point. Okay, so let us see what is the product rule. And in the product rule, the definition is very simple. Basically, you have task T. Okay, and then to complete this task T, you have to complete this task T1, and you have to complete this task T2. Okay, this and is very important, means you have to do this and you have to do this. Okay, and let us assume that you have n1 ways to do this, and for each of these ways you have n2 ways for doing this. Okay, this is very important. Okay, for each of, this is very important, for each, okay, for each of n1 ways, okay, to do T1, we should have, we should have n2 ways, okay, to do T2. So remember, after doing, okay, after doing T1, okay, so I can say after doing T1 for each of them. So this is important, so that is the reason I'm telling you. Okay, so very important. After doing T1, after, once T1 is over, okay, once T1 is over, so I can say after doing T1. Okay, so once this task is over, once you have done this task, then whatever way you do this, okay, it does not matter how you do this, whatever way you do this, there must be n2 ways. Okay, like it does not matter how are you doing this. Okay, whatever way you do this, one of these n1 ways you are doing this, whatever way you do this, there must be n2 ways. This n2 ways, okay, must be there. So these are the two important things. First of all, after doing T1, okay, after doing T1, for each of the n1 ways, for each of these n1 ways, there must be n2 ways to do task T2. Okay, this is important. If this is the situation now, okay, so these are n2 ways. Okay, these are n2 ways after doing. Okay, remember this point is very important. These n2 ways are after, these n2 ways, these are basically after doing T1. After doing T1. Okay, so these n2 ways are after doing T1. These are the n2 ways. Okay, for, okay, so this is important. Okay, so in this situation, how many ways to do this task? Number of ways to do this task, that will be n1 into n2. Okay, so let's take one question. And here one thing also you can notice, and that is also very important. So if you have completely independent task, okay, let's assume T1 has nothing to do with T2. Okay, so this is also very important, because I will tell you actually all these points that I'm stressing. If there is any point on which I'm stressing very much, then it means I'm going to take many questions on that point. Okay, and I'm going to show you that many students will make mistakes on these points. Okay, so that is the reason I'm stressing on these points. So first of all, note, okay, if T1 comma T2 are independent, basic, are independent, don't depend on each other. Okay, are independent means basically they have nothing to do with it either. Okay, are independent means okay, they have nothing, okay, means they don't affect each other basically, or I can say, okay, happening of one of them does not affect another. Okay, happening of one of them doesn't affect another. Okay, if this is the situation, then remember, if this type of situation you have, then product rule is the best. Okay, then basically then apply product rule, then think of product rule. Okay, so let's take this example. Okay, how many different bit strings of length 7 are there? So basically bit strings means, as you know, what is bit string? So bit means 0 or 1. 0 is a bit, 1 is a bit. Okay, so bit string of length 7. So this is a bit string of length 7, you can notice. Okay, so one, okay, this 1 2 3 4 5 6. So this is a bit string of length 7. Okay, as you can see, for example, this is a bit string of length 7. Okay, so like this and so on. Now, how many bit strings of length 7 we have? This is very simple. You can apply the product rule. Okay, for this position, you can notice this position has nothing to do with this position. Correct? Yes or no? Agree? See, this position has nothing to do with this position. This position has nothing to do with this position. These positions have nothing to do with each other. Okay, so very simple. Here you have two choices. Okay, so here you can put either 0 or 1 you can put. Okay, so either you can put 0 or you can put 1. Let me put 0. Once this is done, again you have two choices here. Okay, one, let me put 1 here. Again you have two choices here. So for every position, because these positions have nothing to do with each other. Okay, these positions, or you can say once this task is done, okay, you can do each of these tasks in two ways. Okay, so because in every position you can either put 0 or 1. In every position, okay, in every position you can either put a 0 or 1. So that is the point. Okay, so that's why I can say finally answer will be 2 power 7. Okay, so because you can apply product rule, we have to do this task and this and this and this and this and this and this. Okay, all these tasks we have to do. So finally answer will be 2 power 7 because we have to complete all these tasks. Okay, so this is one example of, okay, product rule. Now let's solve this question. What is the answer? This is GATE 1989 question. What is the answer? How many substrings of all lengths, okay, basically can be formed from a characteristics or from a characteristic of length n? Assume all characters are distinct. Okay, so if all the characters are distinct, then how many strings? Here we will do some variations also. Okay, so let me create one variation also. If all the characters are same, then what will be the answer? Here let me create one variation. If all the characters are same, then what will be the answer? Okay, so first you tell me here, what is the answer here? How many substrings can be formed from a characteristic of from a character string of length n? Okay, so substring is a very simple concept. Maybe you already know. So because if you have let us assume you have some string. Okay, so if you have some string, for example, if you have a a b a c. Okay, so let us assume this is your string. Now for this string, if you substring means basically, okay, if you take consecutive part. Okay, so basically if this is your string, this is your string, this is your string w, then substring means basically, okay, any consecutive part. Okay, so substring basically means any consecutive part. Okay, so substring means consecutive part of it. Okay, consecutive part of the string. Okay, so for example, for this string, how many substrings? So this is your substring, consecutive part of it. So for example, if you have this string a b a c, okay, then this is a substring. Okay, then you can notice, okay, a b a c, then this is a substring, consecutive part of it, a b a c. Then this a is a substring, but we have already counted. Okay, we have already counted. So this c is a substring, a b a c. Then this is a substring, a b a c. This is a substring. Okay, a b a c. This is the substring. Consecutive part you have to take. Okay, so that's the point. Okay, so you can notice this AC is a substring. This AB is a substring. BA is a substring. Like this, you can create ABAC. This is a substring. ABAC. Okay, so ABAC. So like this is a substring. So these are and finally this ABAC. This itself is a substring. ABAC. Okay, this itself is a substring. So this is the concept of substring, means consecutive part of it. Okay, so this is a very simple concept. Now, okay, let me clear one point here. See, here you might be thinking, where is epsilon? Okay, so let me tell you that in TOC, in the theory of computation subject, we use this epsilon. In discrete mathematics, there is no such thing as epsilon. Okay, so basically these TOC people, okay, so these TOC people, they use epsilon. Okay, so they use something called empty string. They use something called empty string. Okay, but discrete mathematics people, they these mathematicians basically, okay, they don't use any empty string type of concept. Okay, so this type of concept, empty string type of concept, is not available for them. Basically they don't use this concept. Okay, empty string basically type of concept is not there. Okay, concept is generally not used, is usually, okay, not used. So anyway, for this question, you don't have to worry actually. Okay, like you might be asking, this question should be, we should treat this as a TOC question or discrete mathematics question. See, any mathematics book if you study, you will never find this empty string. Okay, in the mathematics book you will never find it. Okay, and in the doc book you will find this. Okay, so now this question you don't have to worry. That's the point. Okay, if this question comes in the gate exam, then the marks will be given to you. Okay, so whether you consider the empty string or not, okay, so marks will be given to you. Okay, so you don't have to worry about it. Okay, but anyway, this is a point. In the mathematics book you will never find this empty string type of thing. You will never find in the mathematics book. Okay, so anyway, so what will be the answer here? So the answer is very simple, that if you have basically, if you have n length, okay, if you have a1, a2, a3 and so on an, if this is your string, if this is your string w, then substring means basically length 1, length 2, length 3 and consecutive part you have to take. Okay, so that's the point, you have to take consecutive part. Okay, so here I can say, for example, length 1. Okay, so how many length 1 substring you can make? See, all the characters are different. Okay, all in the question, this question is saying that all the characters are different. All the characters, they are different. Okay, so if all the characters are different, then how many substring you can make of length 1? So you can make total substring of n. Okay, n substrings of length 1 you can make, because this is a substring, this is a substring and so on. Okay, so length 1 substring, total n you can make. Okay, similarly length 2 substring, how many you can make? Again, this is very simple. A1, A2 you can make, A2, A3 you can make, A3, A4 you can make, so n minus 1 you can make. Okay, length 3, so A1, A2, A3 you can make, A2, A3, A4 you can make, A3, A4, A5 you can make, and so on. So n minus 2. If you go like this, then n length substring, that is only one. This, okay, A1, A2, An. Okay, so total on. Okay, so the answer will be basically, the answer will be this. Okay, so final answer, number of substrings, number of substrings, that will be 1 plus 2 plus and so on n. Okay, and this is a very popular series, and the answer is, okay, n plus 1 by 2. Okay, so this is a very popular series, as you know. Okay, 1 plus 2 plus and so on n. Okay, first n natural numbers. Okay, the summation of first n natural numbers, that is n plus 1 by 2. So here the answer will be, here the answer will be either n plus 1 by 2. Okay, or n plus 1 by 2 plus 1. Okay, if empty string not considered. Okay, if empty string not considered, so if we don't consider empty string, okay, here if empty string considered, okay, anyway, you don't have to worry. Okay, for both these you will, okay, get the marks. Okay, so don't worry about it. Okay, so anyway, this is your answer, because you can. Okay, so now if the question is like this, then what is the answer? If all the characters are same, for example, if w is a, okay, if this is your w, then how many substrings are there for this w? How many substrings are there? Okay, so what is the number of substrings for this w? So number of substrings is very simple, because one length one, two length one, three length one, four length one, and five length one. So here the answer will be simply 5, because you can notice, if your string has all the symbols like this a, and so on. Okay, total n characters. Okay, so n characters if you have, then you can notice for length one, if you, okay, length one substring, okay, total one. Okay, so number of substrings and length, I can say. So here this is the chart. Okay, so this is the length and this is the number of substrings. So you can notice length one substring, only one, because only a you can make. Okay, whatever a you take, only one a you can make. Okay, length two, only one, length three, only one, and so on, length n, only one. So finally answer will be total n substrings you can make. Okay, so like this they can ask you. Okay, so this is a simple these type of variations they can ask you. Okay, so they can give you some more variation, like first and second characters are same, and all other characters are different. So any variation they can give you. Okay, so you can handle this question. And remember, don't worry about this. Okay, many students, they waste their time in this. I have seen. Okay, so many students will fight. Okay, some will say that, okay, this is the answer. Someone will say this is the answer, and they will keep fighting, keep fighting. Okay, they will waste a lot of time in these type of silly things. Okay, so don't worry about these things. Okay, so let's go to the next. Now, what is the complement rule? Okay, so what is this complement rule? This is another rule. Sometimes what happens that what I am asking you that you cannot count easily, but what I am not asking you that you can count very easily. Basically, sometimes what is your desired case, what is your desired answer that is counted, that cannot be counted easily, but undesired cases can be counted very easily. Okay, so basically desired cases is equal to total cases minus undesired cases. This is the complement rule. Okay, so this is a very simple rule. Okay, in our real life also we apply this type of rule, correct? So let's see one question. Can anyone try this? Four letter words in English alphabet, how many do not begin with an L? Okay, so how many do not begin with an L? So what is the answer? So here you can apply the method like, okay, just try this. Okay, let me solve this question by two methods. So four letter words this question is asking. Okay, you want four letter words, okay, in English alphabet. So basically you have, okay, 26 characters. Okay, now they do not, that do not begin with L. Okay, that do not begin with L, so it should not be L basically. Okay, it should not be L, this should not be L. Okay, so basically this L should not come here. That's the point. The whole point is L should not be here. Okay, so this definitely this should not be L. So if this is not L, then how many choices you have for this? If this position, for this first position, if L you cannot put, then how many choices you have? How many choices we have? Total 25 choices we have, correct? So you can notice here we have total 25 choices. We cannot put L. Okay, now you can notice, so for this position we have 25 choices, and for the remaining positions we have 26 choices. For every position we have 26 choices. Okay, so here we cannot put L, here we cannot put L, so let me put M. Okay, here we cannot put here we can put anything, here we can put anything. So I can put L, I can put M, I can put, okay, okay, anything. Okay, so for example, okay, I can put, okay, a something. Okay, so you can notice that the answer is what? So by this method one, so the answer, you can apply the product rule here, and the answer will be 26 power 3. So this is the answer. Now the same question we can do by method 2. What is method 2? Method 2 is desired cases. Okay, what are your desired cases? Desired cases means do not begin with L. Okay, do not begin with L. So these are the desired cases. Do not begin with L. Okay, this is equal to total cases. Okay, total four letter words that you can make. So basically total minus undesired. Okay, so what is the total? Total is very simple, 26 power 4. Undesired means basically it should start with L. Undesired means it should start with L. Then undesired cases are basically 26 power 3. So the final answer will be, okay, that will be 26 power 4 minus 26 power 3. And if you take this out, then this is just simply 26 into 5. Okay, so this is another way. The same question you can do in different ways. Okay, so this is how also you can do. Basically desired cases is equal to total cases minus undesired cases. Okay, so this is how you can do. Okay, try this question. Can you do this question directly? Like, okay, in from this question you will understand the importance of the complement rule. Okay, so just try this question. This question is going to tell you the importance of the complement rule. Complement rule means what I'm asking you, don't find that. First find what I'm not asking you. Okay, so basically desired cases is equal to total cases minus undesired cases. Okay, so let's try this question. So here you can very easily you can try this. A student ID is made up of 3 letters followed by 2 digits. Okay, so the student ID basically looks like something like this. Okay, so okay, so anyway, okay, student ID, the student ID is basically you have 3 letters and then followed by 2 digits. Okay, so it's like this. Okay, so for example, okay, GO, okay, GOC, and for example 1 2, okay, 1 1. So anyway, something like this. Okay, So how many student IDs have some repetition, at least one repetition? Some basically means at least one repetition. Okay, so some basically means at least one repetition must be there. So basically this is valid ID, but this is not a valid ID. You can notice, okay, this is not a valid ID. So this is your desired case, I can say. Okay, so this is your desired case. Okay, this is undesired. Now the question is saying some repetition. Okay, which repetition? Okay, first of all, we don't know which repetition, how many repetition. For example, this is also desired case, G 1 1. Okay, this is also desired case. So you can notice we don't know how many repetition. He is saying at least one repetition, but we don't know how many repetition. Okay, we don't know which to repeat, whether to repeat the letter or whether to repeat the this digit. We don't know. So in this situation, you can what you can try, you can just try the complement rule. You can try. Okay, okay, so you can try the complement rule here. You can try, just let's try the complement rule. So what are the total number of cases? So first of all, what are the total IDs without restrictions? Okay, so total IDs without any restrictions. So total ID is possible without any restriction. There is no restriction. So basically, okay, no no restriction on, no restriction on repetition, no restriction on repetition. Okay, so then in that case, total how many? So total will be 26, 26, 26, and then 10, and then 10. Okay, so the answer will be okay, total will be basically 26 power 3 multiplied by 10 to the power 2. So this is the total. Okay, correct. So this is the total number of IDs without any, without this condition. Basically this condition is we are bothered about this condition because this condition is troubling us. Okay, so if you ignore this condition, then the answer will be, okay, 26 power 3 multiplied by 10 to the power 2. Okay, so this is the total without any, no restriction on the repetition. Now what are the undesired? What? Okay, undesired means no repetition. Yes, undesired means no repetition, no repetition. And this is very simple, because you don't want any repetition. Okay, so if you don't want any repetition, then here I can put anything. Okay, I can put any letter, I can put here. So there are 26 ways I can put any letter. Once I have done this task, okay, this task once I have done, okay, for example, if I put let me put A here. Once I put this letter here, I cannot repeat this letter. I cannot repeat. Okay, so because I cannot repeat, so I have 25 choices here. Here I have 25 choices. Okay, so let me put C. Now I cannot put A, I cannot put A, I cannot put C. Okay, I cannot put A, I cannot put C. So there are 24 choices for this position. Okay, so let me put maybe, okay, B. Now you can notice here I have 10 choices and here I have 9 choices, because once I put something here, for example 0, now I cannot put 0 here. I cannot put 0. So that's why, for example, let me put 9. Okay, so this is the answer. So this is your undesired cases. So undesired cases will be 26, 25. Okay, so this is the answer, 26 into 25 into 24 into 10 into 9. Okay, so this is the answer for undesired cases. Okay, and finally you can, what you can do, total cases minus undesired cases, that will be your answer for this question. Okay, so for this question, final answer, okay, final answer, that will be, okay, final answer will be basically 26 power 3 10 to the power 2 minus, okay, 26 25 24 10 9. Okay, so this is how you can do. Is this clear to everyone so far? Anyone has any doubt? Okay, this product rule is very important. Anyone has any doubt right now at this point of time? At this point, anyone has any doubt? Okay, so let's see the next. Okay, in the product rule, what is very important? Okay, like again and again I'm telling you, because in the product rule many students they make mistake. Okay, so what is very important, let me repeat this. Okay, again, because in the product rule, this is very important point in the product rule. Okay, very important in product rule. What is very important? Again, the important thing is, Once you have done, okay, why, okay, what is the proof of product rule? Okay, from the proof of product rule you can see that important point. Basically here you can notice that if you have these tasks, okay, let us assume these are your tasks, or this is your task T1, this is your task T2, this is your task T3, or let me take only two tasks. Okay, so let me take only two tasks. So here you can notice this is task T1, this is task T2. Okay, here you can notice that, let us assume that, okay, if I, okay, let us assume our task T1 can be done, okay, to solve this task T1, what you can do, okay, just give me a second, okay, give me a second, you read this paragraph, okay, right now you read this paragraph, let me correct to charger. Okay, so let's see. So what is very important, did you read this paragraph? Anyone, did you get this paragraph, what this paragraph want to say? Did you get it? Okay, so let me tell you. So for example, let us assume that you have T1 T2. Okay, let us assume that okay, this very important point is this, that to solve this you have total n1 ways to solve this. Okay, total n1 ways. Okay, and remember, for each of these ways, for each of these, let us assume these ways are like this. Okay, these are the A1, A2, and so on, A and 1. Okay, so these are your n1 ways, or I can say maybe n ways. So let's assume that these are total n ways to solve this. To solve this, we have total n ways, and these are the n ways: A1, A2, An. Okay, so these are the n ways. Now, for each of these ways, you must have m ways. So remember, m ways. Okay, m ways. Conditions are these. Okay, after T1, first of all, after T1 is done, after T1 is done, and the second point, so these m1 m ways must be there after T. Once this is done, so what I'm saying is, okay, so you have m ways. Okay, after T1 is done, for each, okay, so for each of n ways of T1. Okay, so for example, if you do, let us assume you do this by A1. Okay, let us assume you put A1 here. Okay, then for this A1 you must have total m ways. Okay, let me put instead of A1, if you put A2, then also you must have m ways, and so on. Okay, if you put An, then also you must have m ways. If this situation is satisfied, for each of them you have m ways. Okay, then you can apply the product rule, and then finally T1 and T2 can be done. So finally I can say that, okay, T1 and T2 can be done in, okay, mn ways. Okay, so because you can notice, okay, for each of them you have m ways. Okay, here m ways, m ways, m ways, like this. So finally total how many ways you have? M plus m plus m plus m plus m plus, like, okay, like this, m into n. So this is your proof. This is the proof of product rule. Okay, now this product rule is not applicable when you have this type of situation. Okay, consider this situation. Let us consider this is scenario or situation. Let's consider this situation. In this situation, the product rule will not be applicable. For example, let us assume, okay, let us assume for A, okay, this is T1 and this is T2. Let us assume you do this by, okay, for A, let us assume you have 5 ways. Means when you do this task by, okay, by this way, then you have 5 ways of doing task T2. When you do this task, then also you have 5 ways. When you do this task like this, then also you have 5 ways. And if you do this task like this, then you have 4 ways. Now tell me, okay, now just tell me, okay, what are the total number of ways to do T1 and T2? Tell me. what are the total number of ways to do T1 and T2. So you can notice this is a 4 ways. So you can notice this is a 4 ways, and these are the 4 ways A, B, C. Okay. So what are the total number of ways? Okay, number of ways to do T1 and T2. Number of ways to do T1 and T2. What is that? That is your 19, correct? Yes or no? That is 19, not 20. That is not 20. What is the mistake? What is the mistake? Mistake is this. And what is the mistake? Mistake is you have 4 ways, okay, here, and you have 5 ways here. This is the mistake. So this is the mistake. Okay. So is this point clear to everyone? Is this point clear to everyone? In this situation, what to do? In this situation, what to do? In this type of situation, like when you have something exception, let me call it exception. Let me call it exception. So you handle separately. This exception you should handle separately. Yes. Okay. Yes or no? So in this type of situation, okay, let me call it exception. So let me just tell you, in this type of situation, what you have to do? Let's call it exception. So basically, you create cases. You create case 1 and you create case 2. Okay. What should I do? Case 1, case 2. What should I do? Multiply or plus? What should I do? Case 1, case 2. What should I do now? Now, these must be added. These must be added because summation rule. Because of the summation rule. Okay. Why I can apply summation rule? Because these are completely different from this. Okay. These ABC, these ways are completely different from this way. So here I can apply the summation rule. Okay. So like this you can do. Okay. So let's take one question. Okay. Try this question. Try this. So here, what is the common mistake? Let me tell you. Okay, so what is the common mistake among students? Okay, what is the myth? So what is the common? First, let me tell you the common mistake. You try this question and then let me tell you the common mistake. Not starting with the 0. It should not start with 0. Means product rule applicable when events are dependent and summation rule applicable when events are independent or different. No, Vidyasagar, like these rules you can apply in many different situations. Okay. So as I told you, for example, if you are, first of all, don't bring the event word here, because in probability you study independent event. Okay. So I'm not talking about those things. Okay. I'm not talking about probability independent events. Okay. There is a definition of independent events in probability. There is a definition. Okay. You know what is that? Okay. PA intersection B is equal to PA into PB. Okay. So that is your definition for independent event. Okay. So don't confuse these things with that independent event definition. Okay. So let's try this. Okay, 4-digit pin codes. So what is the answer here? So the answer is very simple. 4-digit pin code you want, not starting with 0. It should not start with 0. Okay. So basically this should not start with 0. Means here I cannot put 0. So here I have to, okay, total 9 choices I have. Okay, total 9 choices I have. I cannot put 0 here. Remember, I cannot put 0 here. So let me put 2 here. Once this is done, now I can do this in 10 ways, in 10 ways, in 10 ways. So finally answer will be 9 into 10 to the power 3. Okay. So here the answer will be 9 into 10 to the power 3. Correct? Okay. So the question is saying how many 4-digit pin code are there not starting with the 0. Okay. So total 9,000. These many pin code will be there. Now in this question, let me create some variation. Okay. Variation let me create without repetition. Okay, so let me just create one variation here. Let me create one variation which is without repetition. Okay, without repetition. Now try without repetition. Now what is the answer? If there is no repetition, okay, because there is no repetition, so you can notice first of all here you cannot put 0. Okay, so you have 9 choices here. You cannot put 0 here. I cannot put 0. But now, okay, now because I cannot allow repetition, so I cannot put 2 here, I cannot put 0 here. In this position, just think about it. In this position, I cannot put 2, but I can put 0. Sorry, I can put 0, but I cannot put 2. Okay, so again, I have nine choices here. Now I cannot put 0, I cannot put 2. So let me put 3. Okay, so here you have 8 ways, and then finally here you have 7 ways. So the answer will be 9 into 9 into 8 into 7. Okay, so this is the final answer. Correct? Okay. Okay. So let's try this question. What is the answer? Yes, 0100 is also a pin code, right? If they do not mention anything, then this is also a pin code, correct? That is the reason they will mention it explicitly, they will mention it. Okay, so you don't have to worry. Correct? Let's try this question. Okay. Okay, so let's see. So how many 4-digit numbers are there? Not starting with 0 without repetition. Also must be an even number. Okay. So first of all, let me try this. Okay, and this must be an even number. So is it correct? Okay, let me try this. Okay, so you want 4-digit numbers. Okay, which should not start with 0, which should not start with 0. So here I have no 9 ways. Here I have 9 ways because it should not start with 0. So I have 9 ways. Okay, let me put 2 here. Okay, let me put 2 here. Now without repetition, so again I have 9 ways. Okay, here I have 8 ways, and then here I have 5 ways because it must be an even number. It must be an even number. Is this correct? Is this correct? What is wrong with it? The question is, what is wrong with it? First of all, this is wrong. First of all, this is wrong. But what is wrong with it? Where is the mistake? Find the mistake. That is the point. Okay. What is the mistake? There is something wrong with it. Yes, because first of all, see, you are applying product rule, and the product rule says that whatever you do here, whatever you put here, this setting should not change. Whatever you put here, this setting should not change. Correct? This is what product rule says. Yes or no? Whatever you do here, this setting, whatever you put here, whether you put 0, 2, 3, 4, 5, with whatever you put here, this setting should not change. Why this is wrong? Because why this is wrong? Because if you put 2 here, just think about it. See, if you put 2 here, then here I have 4 ways. But if you put 3 here, then I have 5 ways. Can you notice the difference? Okay, so that is the reason. Okay, so directly product rule you cannot apply. Okay, so the product rule you cannot directly apply. Yes or no? This is the point I'm trying to tell you. Product rule cannot be directly applied. Cannot be directly applied. So what should I do? Okay, what should I do? So okay, now we need cases. So just try the cases. Okay, so basically case 1. What is case 1 and case 2? Case 1 is basically, and here one more thing is there. One more thing is there. Okay, so anyway, if you put 2 here, then we have 4 ways. If you put 3 here, then we have total 5 ways. So okay, anyway, So now let's try the case. Okay, so what are the cases we can create? 0 should not be in the first place. Okay, so anyway, so first you can try like this. Okay, do we have 0 here? Okay, so let's go from this side. Okay, like do we have 0 here? And we don't have 0 here. Or what you can say, or what you can do actually like this you can create the cases. Also you can create like this. If you have odd number here, for example, if you have 3, okay, let us assume if you have odd number here, then in that case how many ways we have? Total 5 ways we have. Okay, so because you have odd number here, now once I put this odd number here, now how many ways I have here for this position? Because I'm putting odd number here, how many ways I have for this position? That is total 9 ways, because now I can put 0 here. Okay, now, okay, actually after this do let's do this. Okay, so once you put odd number here, then 5 ways here. Now let's put something here. See, once you put this odd number here, this odd number 3 you put here, then because this is the restricted place. See, what are the restricted places here? Okay, let me tell you. So these are the restricted places. Okay, so this and this, these are the restricted places. I can say these are the restricted places. So when you have restricted places, when you have some restriction, then you do them first. Okay, so this is just a rule. Okay, this is just a general rule. I can say this is just a general observation that, okay, complete them first. Okay, so you can notice here, if you okay, after this you have 5 ways to do this task. Okay, whatever you put, for example, if I put 0 here, now you have how many ways you have 8 ways here, and then you have how many ways? Total 7 ways you have. Okay, now what is case 2? Case 2 means you are putting some even number here. Okay, case 2 means you are putting some even number here, but that even number is not 0. So here you have even but not 0, but not 0. Okay, so how many ways? Even but not 0. So how many ways? Total 4 ways. You are putting some even number, but that is not 0. So total 4 ways. Okay, now once this is done, now how many ways here? Now total 4 ways. Okay, now you can put 0 here, there is no problem. Now there is 8 ways, and there is total 7 ways. Okay, so the answer, finally the answer will be what? It is not necessary to put odd number, last digit should be even. No, that is the reason I am creating cases. See, this case will take care when first digit is odd, this will take care when the first digit is odd, and this will take care when the first digit is even. And you can notice the first digit is not 0, and you can notice that the last digit is even number. Yes or no? Okay, so finally you can just add these two cases. Okay, and the answer will be what? 5 into 7 into 8 into 5 plus, okay, 4 into 7 into 8 into 4. 4 into 7 into 8 into 4. Okay, so is this your answer? Tell me, this is correct? Okay, so this is the answer, right? So you can notice that basically I am creating two cases I am creating. In the first case, here the first digit is, I can say first digit odd. Here I can say first digit odd. Okay, and here first digit is non-zero even. First digit non-zero even. Even but not 0. First digit even but not 0. Okay, so this should be an even number, but it should not be a 0. Okay, so like this you can do. Okay, okay, so like this you can do. So just take care. Now let's try these questions. Okay, quickly you tell me the answer for these questions. These are some questions for your practice. You can just try them. Quickly try. Determine the number of 6-digit integers. So what is the answer? So what is the answer for this question? 6-digit integers, no leading zeros. Okay, no digit may be repeated. Should not repeat any digit. So then what is the answer for A? So the answer for A is very simple. You should not repeat any digit. Okay, total 6 you have. Okay, and you can notice the leading that should not be a zero. So this should not be a zero. So here you have 9 ways because this should not be a zero. Okay, so you can put something. For example, you can put 8 here. Now you can notice for this position you have again 9 ways, and then you have 8 ways, then you have 7 ways, then you have 6 ways, then you have 5 ways, because there's no repetition. Okay, so here for A the answer will be okay 9 into 9 into 8 into 7 into 6 into 5. So this is the answer. Correct? Okay, so like this you can do. So this is your A part. What is the answer for B? Digits may be repeated. Digits may be repeated, but here you should not have zero. Okay, so again here you have 9 ways, but on every position, on every other position you have 10 ways, 10 ways, 10 ways. Okay, so for every other position you have 10 ways. Okay, so 9 into 10 to the power 5. Okay, what is the answer for this? No digit may be repeated and it should be even number. Try this quickly. Try this. No digit may be repeated, but it should be an even number. No repetition and it should be an even number. This we have done right now. This we have done. In this situation, we have to create cases. Okay. So here you have to create cases because first of all, what is wrong? Okay, what is wrong? Okay, so you can notice this is wrong. If you do like this is wrong. Okay, so first let me tell you 3. Okay, so for example, if you do like this, for example, here 9 ways. Okay, here 9 ways if you do, and here 5 ways if you do. Okay, and then if you do like this, okay, so 2 you have put, then 8, then 7, okay, and then 6, then 5. So this is actually wrong. This is actually wrong. And why this is wrong, this I already told you. Okay, the reason this is wrong. Why wrong? Why this is wrong? The reason is this. Okay, because you can notice that if you put, for example, if you put 2 here, then how many ways? Then I have only 4 ways. Okay, but if you put, just assume that if you put 3 here, then how many ways? Then total 5 ways. So you can notice, so that is the reason. So create cases. So create cases. So you can create cases. Okay, so just let's create cases now. Okay, so finally answer will be, okay, the case 1. Case 1 means first digit is odd. Okay, so let me put the first digit to be odd. So here I have 5 ways. If I put a odd here, if I put something odd here, okay. Now you can notice this is the next restricted place. Okay, this is the next restricted place. So here again you have total 5 ways because here you must put an even number. And now the answer is very simple. Okay, now this is 8, this is 7, and this is 6, and this is 5. Okay, and what is the case 2? Case 2 means you are putting non-zero even number here. Okay, so you are putting basically non-zero even number. Non-zero even. Okay, so how many? Total 4 ways. Now once you have done this task, now how many ways to do this task? Now you have total 4 ways to do this task. And then finally this is 8, 7, 6, 5. Okay, so you can just add, okay, case 1, case 2, you can add them. That is your answer. Okay, you can just add case 1, case 2. Is this clear? Is this clear to everyone? Okay, so here you can just create cases. Now next, digits may be repeated, even number. What is the answer? Maybe repetition is allowed, but it should be even number. So what is the answer for D? Repetition is allowed and it should be even number. So this must be even number. This must be even number. Okay, so very simple. Here you have 9 choices because you cannot put 0 here. Okay, so whatever you put here, here you have 5 choices because it should be even number. So here you have 5 choices and everything else is 10 choices. Everything else is 10 choices. So the answer will be 9 into 5 into 10 to the power 4. Correct? Is this clear to everyone so far? Okay, so this is very simple. Okay, 9 into 5 into 10 to the power 4. What is the answer here? No digit may be repeated, divisible by 5. No digit may be repeated, divisible by 5. No repetition, but divisible by 5. What is divisible by 5 means? This means the last digit, 0 or 5. The last digit must be 0 or 5. Okay, that is the meaning. Last digit must be 0 or 5. No repetition. So finally here, okay. Now tell me, is this correct answer? If I do like this, for example, here you have 2 choices. So here you have 2 ways. And here you cannot put 0. So here I have 9 ways. Okay, no repetition. So 8, 7, 6, 5. Is this correct? Tell me, is this correct? Again, this is wrong. Again, this is wrong. Why this is wrong? Why this is wrong? See, this is wrong because you can see why this is wrong. Because if I put if the last digit is 0, then how many ways I have? If the last digit is 0, then how many ways I have here? And if the last digit is 5, tell me how many ways? If the last digit is 0, then how many ways I have? Total 9 ways. But if the last digit is 5, then I have 8 ways. So create cases. So again create cases. Yes, yes or no? Is this clear to everyone? So again create cases, because if you put 0 at the last position, then 9 ways here. If you put 5 in the last position, then 8 ways here. So that is the reason. So finally you can create cases and you can, okay, so what is the case 1? Case 1 is basically when you are putting 0 here. Okay, let me put a 0 here. And what is case 2? Case 2 is basically when I put 5 here. Okay, so now tell me, now quickly tell me, if I put 0 here, then at this position I can put anything. So total 9 ways I can, okay, I can put anything, okay, any of the remaining. Then I have 8, then 7, then 6, then 5. If I put 5 here, I cannot put 0 here. So I have 8 ways here. Now I can put any of 8, 7, 6, 5. Okay, so this is your answer. Is this clear? Is this clear to everyone? Is this clear? See, these are very simple questions. Combinatorics is not hard. Okay, just think about it. Okay, these are very simple. No digit may be repeated, divisible by 4. Quickly tell me. Okay, let no digit. So basically, okay, this is the last case F. Divisible by 4, no repetition. Okay, what divisible by 4 means? Can anyone tell me what this means? Yes, basically what this means, okay, this means the last two digits. What are the last two digits? What are the last two digits? Okay, so this is what you need to see. Last two digits, they must be divisible by 4. Okay, so last two digits can be 0 0. Last two digits can be, okay, 0 4, or you can say 0 8. Okay, and you can say, okay, so when then you can say, okay, 1 6, correct? Okay, and 1 1 2 1 6. Okay, so I can say 1 2 1 6, 1 2 1 6. Anything else? Okay, so like this you have many cases actually. Okay, 1 2 1 6, then you have 2 0. Okay, then you have 2 4, and then you have 2 8. Okay, and then you have, okay, 3 2 3 6 4 0 4 4. Okay, 4 8, and then you have 5 2. Okay, so like this you just keep going on. Okay, so there are many choices actually. Okay, now let us remove some choices. Okay, let us remove some choices actually, because no repetition. The question is saying no repetition, so let's remove some choices, because the question is already saying that there should be no repetition. So let me create two cases. One where last digit is 0. Okay, so let me create two cases. Okay, so here last digit is 0, and another where last digit is not a 0. Okay, so this is a not a 0. Okay, so let me create these two cases. Case 1 where last digit is already 0. Okay, so last digit is already 0. Now tell me how many ways for this second last position. Tell me. See, okay, because you can notice there are too many, okay, last two positions. So what I can do, case 1 last position is a 0. Okay, and case 2 where last position is not 0. Okay, so how many? So here, because I am putting 0 here, 1 2 3. Okay, so then how many I have here choices? So I can put, you can notice, I cannot put 0 here because no repetition. I cannot put 0 here. Okay, I cannot put 1. I can put 2. I can put 3 4. Okay, and then 5 6, and then 7 8. Okay, that's it. Okay, so these are the four ways. These are the four choices here. So here I have four choices. So here I can say total four ways. Now, once this is done, now this is very easy, because now what you can do, total 8 choices here, total 7 choices here, total 6 choices here, and total 5 choices here. So this is your case 1 when the last digit is 0. Now, when the last digit is not 0, then case 2 when your last digit is not a 0. Okay, so then in that case, how many? If this is not 0, okay, then how many I have? We have, and there should be, we need to check for each. So I think this will be lengthy a little bit. Okay, this question will be a little bit lengthy, because if you don't have 0, okay, the last digit is not 0. Yes, there will be some more cases. I think this is a little bit tedious question. Okay, so we can do this. Okay, let me just do here. Last digit is okay. This, then we can create 4. Okay, maybe we can create for 2 also, and so on. We can fix last two positions. Okay, so yeah, maybe we have to put like this. Okay, so maybe case 2, case 3. Okay, maybe case 3 will be this. Okay, maybe this 4, and then case 5, case 0, case 1, case 2. Don't have last digit 0 then. Okay, so little bit tedious, I think. Okay, So anyway, can you try? Actually, this question you can solve if you create cases. Okay, so for example, if you put 2 here, then how many cases, then how many choices we have? For example, if I put 2 here, then okay, 0 1, then I can put 1. Okay, then 2 3 4. Okay, and then 5. Okay, so then we have 5 choices. Okay, so like this actually. Okay, it seems like a tedious question, but like this you can do like case 2. Okay, so this is the case 2, and then you can create case 3. Okay, so like this you can create, so that there will be case 3. For example, if here you have 4 here. Okay, case 2 second. Okay, so like this you can create maybe. Okay, here what is the answer? Here you have 5 choices here. Okay, so here you have 5 ways, and then you can, what you can do, because now 0 here you should not have 0. Okay, you can notice here you should not have 0. So here you have total 7 ways, and now you can put 0 here. So again there is 7 ways, there is 6 ways, there is 5 ways. This is your case 2, and so on. Okay, like this. Okay, just try this. Okay, just you can just try. Okay, in the gate exam, I don't think they will ask you these type of tedious questions. Okay, so you can try. Okay, maybe there is a better way. Okay, some students are suggesting some better ways. Okay, so you can try those ways also. Case 3 and so on. Like, okay, this is okay. So maybe okay, case 4, case 5. Okay, so maybe these are the some cases. Okay, either you can do like this, or there is another approach. Okay, method 2, like some students are suggesting. So if we have 0 in the last 2 positions, then how many? And if we don't have 0 in the last 2 positions. Okay, so if we don't have 0 in the last 2 positions, then I think someone is saying that okay, someone is saying without 0, how many? 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. Okay, maybe 16 ways are there without 0. Okay, so you can, maybe you can try. Okay, anyway, okay, just you can try this. Anyway, this is just a tedious question. Okay, let's try this question. Get 2001. What is the answer? What is the answer here? 4-digit even numbers. Okay, so how many 4-digit even numbers having all digits different? Okay, so this we have already done. So basically 4-digit even numbers the question is wanting. Okay, so this we have already done this. So here actually, okay, let me tell you here. Method 1 is you make cases like this. Okay, so case 1 you make where you have 0 here. Okay, and case 2 you make where you have non-zero here. Okay, so in this case, what will be the answer? Tell me. If you have 0 here, then what is the answer? Because you have 0, so you have 9 ways here, and here you have 8 ways, and here you have 7 ways. Because you have non-zero even, so there are total 4 ways, and now 0 is not here. Okay, at this last position 0 is not here. Okay, then in that case you cannot put 0 here, so there is 8 ways, and then there is total. Okay, now you can put 0 here, so total 8 and 7. So finally, by this method 2, the answer will be 9 into 8 into 7 plus 8 into 8 into 7 into 4. Okay, so either you can do this, or what you can do, method 2. What is method 2? Method 2 you can do like this. Okay, case 1 where you have odd number here. Okay, if you have odd digit here, and case 2 where you have even digit here. Okay, so so these are the two methods. You can see this same question you can do by two different methods. This is case 1, case 2. In this method, what I am doing, the last digit is 0, and this is non-zero. So these are the two cases. Here the last digit is 0, here the last digit is non-zero even. Okay. But here, what I am creating the cases, here odd digit means total 5 ways. Okay. So there are total 5 ways. And then what you can do, then here we have 5 ways. And then what you can do, then you have total 8 ways here, and then total 7 ways here. Okay. And here, okay, you have even non-zero. So there are 4 ways. Okay, now once you put here, then there are total 4 ways again here. Then you have total 8, and then you have here 7. Okay, so are they giving same answer? Can anyone check? Can anyone check? Are they giving same answer? 5 into 8 into 7 into 5. This plus 4 into 8 into 7 into 4. Can anyone check? This answer, okay, can anyone check? Can anyone calculate? What is this answer? Okay, just calculate. If you have a calculator or something, you can just calculate. Okay, so you can just try this. So I think both will give you correct, both will give you same answer, right? Both of them. Calculate this with calculator. Can anyone tell me what is this value? Same? Yes. Okay, so both will give you same answer. Okay, so this is your GATE 2001 question. But remember, don't make this mistake. The common mistake, don't make this mistake. This is the mistake that students will make. Okay, that here you have 9 ways, here you have 5 ways, and then here you have 8, here you have 7. This is the mistake. This is wrong. Okay, this is wrong. Okay, so let's go. Now let me tell you, this product rule has many applications. Okay, in many situations you can apply this product rule, but you can notice that there are some particular situations where this is like you should always think about product rule. Okay, see, product rule has many applications. I am not saying that this is the only application, even though product rule can be applied in many situations. But okay, product rule is particularly based in which situation? When you have n tasks and they are completely independent of each other. They have nothing to do. Basically, they don't affect each other. Okay, so in this type of situation, when you have basically n tasks you have and they have no effect on each other. For example, okay, example 1, how many 6-digit numbers, no leading zeros are there? Here you can notice that these positions have no effect on each other. Yes or no? These positions, this position P1, position P2, position P3, position P4, P5, P6, these positions have no effect on each other. Okay, because you can notice this position has nothing to do with this position. This position has nothing to do with this position. They have no effect. They do not affect each other. So finally, here you have 9 ways and here you have 10 ways. Okay, because they don't affect each other. Yes or no? Is this clear to everyone? Because these positions, they do not affect each other. In these type of situations, when you have n tasks and these n tasks do not affect each other, they are completely independent of each other. They do not affect each other. In these type of situations, you should always think about product rule. So here the answer is very simple. Okay, so this is the answer. Try this question. How many subsets of a set of n elements? So basically a set S has cardinality n. How many subsets are there? Can anyone tell me? How many subsets are there? The answer is 2 power n, but see, okay, but see how can you apply the method? Here, okay, can you notice that you have a set. In this set, you have A1, A2, and so on, AN. Can you notice one very interesting thing that here these elements have no effect on each other. Okay, this is okay. You want a subset. You want a subset of S. Okay, so this is your subset of S. Now, in this subset of S, just tell me this point. Okay, this point I want to ask. This A1, will it affect A2? See, this A1 has independent choice. This A2 has independent choice. This A3 has independent choice. This A1 can choose whether it want to be in the subset or not. This A2 can choose whether it want to be in the subset or not. This AN can choose whether it want to be in subset or not. So they have no effect, though they have no effect on each other. Yes or no? These elements, all these elements, they don't have any effect on each other. Yes or no? They have individual choices. Okay, this is individual choices. Two individual. Okay, two choices here. Here also two choices. They have individual choices. Yes or no? They don't see each other. They are not affected by each other. They have two choices. Each of them has two choices because each of them can decide whether they want to be in the subset or not. Each of them. This AN can decide whether it want to be here or not. So everyone has two choices. So finally, how many subsets we can make? Number of subsets is equal to 2 power n, because each element has two choices. Each element can decide whether it want to be here or whether it don't want to be here. Okay, and you can notice this A2 is not going to affect A3. No, they have individual choices. So this type of situation I call individual choices. Okay, so remember this type of situations I just call it individual choices. Individual choices scenarios. For example, here you can notice here this position has individual choice. Okay, this has 10 choice, 10 choice, 10 choice. So each position has individual choices. They are not affected by each other. Okay, so this type of situation I call individual choices scenario. In this, okay, think about product rule. Anyway, let's see this question. How many if you have set A whose cardinality is M and set B whose cardinality is N, then what is the cardinality of A cross B? Can anyone tell me? Cartesian product. What is the Cartesian product? If you have set A, okay, for example, if you have A, B, okay, this is your set A, and let's assume this is your set B, which is B comma C, then you can notice these are the two sets. Okay, here you can notice the cardinality of A means number of elements in A, that is 2, number of elements in B, that is 2, and you can notice what is A union B. The union means basically all the elements. Okay, union means all the elements. So A will be here, B will be here, C will be here. This is the union. So what is the cardinality of union here? Here the cardinality of union is 3. Okay, what is the intersection? The intersection means common elements. So here the common element. Okay, so what is the cardinality of intersection? That is 1. What is A minus B? A minus B means in A but not in B. In A but not in B means exclusively in A. So what are the elements which are exclusively in A? That is only A. What is B minus A? B minus A will be C. Okay, and what is this symmetric difference? Symmetric difference means union of A minus B, B minus A. Okay, so that will be A comma C, because you can notice these are the okay A symmetric difference. This is called symmetric difference. Okay, and this is another symbol for it, exclusive OR. This is basically nothing but A minus B union B minus A. Okay, actually the best way is, okay, basically here I can say those elements which are exclusively in A or B. Okay, those elements which are exclusively in A or B means they should not be in both. Okay, either it should be here or it should be here. It should not be in the both positions. Okay, so this is your exclusive OR. Similarly, you can notice what is the Cartesian product. Cartesian product means this is the set of ordered pairs. Okay, the first element will come from A, the second element will come from B. So first element is coming from A, the second element is coming from B. So here it will be A comma B. First element coming from A, second element coming from B. So it will be A comma C. Then it will be B comma B, and then it will be B comma C. Because the Cartesian product is very simple. If you have, okay, so this is the Cartesian product. You can notice A cross B means this is your A comma B, and this is your B comma C. Then Cartesian product means basically, Cartesian product means A with B, A with C, okay, and B with B, B with C. So this is your Cartesian product. So what is the cardinality of Cartesian product? You can very easily see that is M into N. But how this is coming? Okay, how this is coming? This is coming because you can notice that in the Cartesian product we have, first of all, in the Cartesian product we have ordered pairs. Okay, we have ordered pairs x comma y, where x is coming from A and y is coming from B. Okay, so here you can notice that this is A cross B. Every element x comma y, here you can notice x is coming from A and y is coming from B. Now tell me one thing. See, x is coming from A, y is coming from B. This is coming from here, and you can notice this is coming from here. Tell me, do they affect each other? X comma y. Do they affect each other? No, because x is coming from A, y is coming from B. So they are completely individual. Okay, so I can say that here you have total these many choices for A, for x, these many choices for x, and here you can notice these many choices for y. So you can notice they do not affect each other. This is the simple point. Okay, this x comma y, they do not affect with each other. So for this x we have these many choices, and for this y we have these many choices. So finally the Cartesian product cardinality will be x in, okay, that will be cardinality of A multiplied by cardinality of B. Okay, so like this. Now this symmetric difference actually you can see like this. Okay, see, if you have this set A, this is set B, then what is the union and all these things we can check. Okay, so for example, this is set A, this is set B. Let us assume this is set A, this is set B. Then what is the union? The union is this whole area is the union. Okay, so you can notice this is the Venn diagram, and this whole area is the union. Okay, so this is A union B. And can anyone tell me what is the cardinality of A union B? A union B cardinality, you can notice what is that? That is cardinality of A plus cardinality of B minus the common area. Because when you do this cardinality of A plus cardinality of B, then this area, this common area you have counted 2 times. Yes or no? So here you have counted, this common area is counted 2 times, this common area. Okay, so that common area is counted 2 times. I can say that A intersection B is counted 2 times. Is it counted 2 times? So you have to remove it 1 time because you have counted it 2 times. Anyway, just remove it 1 time. So finally, what I can say here, okay, what is the maximum value of A union B? Can anyone tell me? If I ask you, what is the maximum value of A union B? Means what is the maximum cardinality of A union B? That will be when we will get maximum cardinality, when they are disjoint. Yes or no? When they are disjoint, then we will get maximum cardinality. And what is the minimum cardinality? Maximum cardinality we will get when they are disjoint. And what is the minimum cardinality? Can anyone tell me? Minimum cardinality. So you can notice maximum A union B, when you will get that will be this. Okay, so you can notice maximum value that you will get is this when A intersection B is 5, means A comma B disjoint. Okay, and when you will get minimum, what is the minimum cardinality? A union B. What is the, when you will get minimum cardinality? That will be minimum of A cardinality comma B cardinality. Basically, when one is subset of another, when one of them is subset of another. For example, if you have this type of scenario, sorry, this will be max. Sorry, this will be max. When you have this type of scenario, then in this case you can notice A union B cardinality is equal to A cardinality. So when you will get minimum that you will get is in this situation, you will get minimum. Okay. Anyway, okay. So these these very basic points you already know. Okay. So anyway, you can just check it. Let me just explain what is A minus B. This area is the A minus B area. This area is A minus B area. And you can notice this area is A intersection B area. And you can notice this area is B minus A area. So finally, you can notice that what is the symmetric difference? A symmetric difference B, that is A minus B union B minus A. Okay, so finally, what is that? That is your A union B minus A intersection. Correct? Yes or no? Because this is the symmetric difference area. Okay, so if you have this is A, this is B, then you can notice that this area is the symmetric difference area. So this red area is your A intersects A symmetric difference B. And this is nothing but union. From the union, you can remove the intersection. The common part we are removing. Okay. So anyway, this is your symmetric difference. And so, okay. So like this you can do. Okay. Anyway. Let's see the next question. Okay. So can you try this question? So this is your GATE 2003 question. N couples are invited to a party. There are total N couples. Okay. You are inviting them to a party. The condition is that every husband should be accompanied, okay, whatever this, okay, accompany, okay. So by his wife. So basically, if husband is coming, definitely his wife must come. Okay. So you can notice there are total N couples. If husband is coming, then definitely his wife is coming. But if wife is coming, then husband may or may not come. Okay. However, a wife need not be with his husband. Okay. So how many different gatherings are possible? So here you can notice total N couples you have. N couples you have total. Okay. H1, wife 1, husband 1, husband 2, wife 2, husband 3, wife 3, like this, husband N, wife N. And the condition, what is the condition? The condition is that if husband is coming, then definitely wife should come. Okay. So you can notice if husband is coming, then wife should come. Okay. But if wife, basically H implies W. Basically, if husband is coming, then definitely wife should come. W should come. But if W is coming, then H can come or not. Okay. So basically, this is the point. Okay. So you can notice this is the situation. Now you can notice one thing here. How many possible gatherings are there? So you can just tell me this point. Okay. This is the point I want to ask you. Tell me, this couple, will it affect this couple? This couple, will it affect this couple? No. Similarly, this couple is not going to affect this couple. So basically, these are individual couples, I can say. Okay. See, this has no effect on this. They are basically unaffected by each other. Correct? Okay. So they can take decision. For example, H1, W1, they can take decision. So how many choices H1, W1 has? Okay, just tell me this one. How many choices they have? How many choices? So total 3 choices they have. Okay, so they have total 3 choices. What are the 3 choices? So the 3 choices are like this. Okay, so a husband can come, wife can come. Okay, so both can come. Husband and wife both are not coming. Husband is not coming, wife is coming. So these are the 3 choices. Okay, these are the valid choices, I can say. These are valid. But this is not valid. That husband is coming, wife is not coming. This is invalid. This choice is invalid. So every couple has 3 choices. Every couple. This couple has, okay, every couple has 3 choices. Okay, so H1WN has 3 choices. H2W2 has 3 choices. Okay, like this. Okay, so this has 3 ways. And so on. H and WN. This also has 3 ways. Every couple has 3 ways. So finally answer will be 3 power n. Okay, so here the answer will be 3 power n. So 3 power n possible. Okay, let's see this get. See, can you notice one thing here? Okay, the interesting thing that you should notice. Okay, why I'm saying this again and again, because here you can notice these are the entities. Okay, these are the entities which are individual entities. H1WN are not individual entities. Here, these are the individual entities. Can you notice? Yes or no? In this situation, I can say, H1W1, H2W2, and so on, H and Wn. Can you notice that these are individual entities? They can take their own decisions, individual entities. Yes or no? So here this has three choices, here this has three choices, here this has three choices. So finally we have total 3 power n choices. Okay, so like this and so on. Okay, let's solve this question. This is TIFR 2012 question. How many pairs of set A comma B are there that satisfy the condition A comma B both must be subset of 1 to 5 and their intersection must be 5? Quickly tell me. So basically A comma B, these are subset of 1 to 5 and their intersection must be 5. The intersection must be 5. So how many such pairs are there? How many such pairs? These type of pairs. How many such pairs are there? For example, let me explain. For example, you can take A, you can take as 1 comma 2, B you can take as 3 comma 4. Then you can notice A comma B. This is fine. Okay, so basically like this you can do. Okay, for example, you can take A as this, B as this. For example, you can take A as this and B as, for example, you can take A as 1 and you can take B as 5, something like this. Okay, so these are some examples. So how many such possible pairs you can make? Okay, so this is what the question is asking. And also here A can be 3 comma 4 and B can be 1 comma 2. So all these you have to count. So here again you can notice that first of all A comma B, they are subset of 1 2 3 4 5 first of all, and you want these A, these B. Okay, so it's like this. You have here you have A and here you have B, and the condition is that they must not have any common element. They should not have any common element. A intersection B must be 5. So here you can notice that if I am putting 1 here, just think about it and tell me, if I am putting 1 here, can I put 1 here? If I am putting 1 here, can I put 1 here? No. For 1, how many choices I have? For this 1, how many choices I have? So you can notice here how many choices I have for this 1. Okay, how many choices I have for this 1? 1 2 3 4 5. For this 1, how many choices? Okay, so for any particular element, how many choices you have? Okay, so for let's call it S. So for any X belonging to S, 3. Okay, how many choices you have? Okay, so these are the choices. So you can notice that. Okay, and we want A, B. What are the choices? The choices are very simple, that this is A, this is B. X can be, okay, there is, okay, nowhere. X is not in A, X is not in B. X is in A, but not in B. X is in B, but not in A. So these are the choices for X. Okay, this is not a choice. This is not allowed. This is invalid. So finally, I can say these are the valid choices. Each element has these 3 choices. Either it is not present in any of them, or it is present in exactly one of them. So total 3 choices each element has. So every element has 3 choices. So finally, I can say that, okay, 1, 2, 3, 4, 5, and every element has 3 choices. Every element. So finally, answer will be what? Answer will be 3 power 5. If there are n elements, then answer will be 3 power n. Okay, for n elements, I can say, okay, if you have total n elements, then answer will be 3 power n, because every element has 3 choices. This is TIFR 2010 question. Can you try this? TIFR 2010. So in this question, what he's saying, okay. So in this question, he's saying that let X be a set of size n, and what are the pairs such that, okay, basically again, the question is again same, A comma B, and this A comma B, they must be subset of X, and there is one more condition, A must be subset of B. So this is like this, okay, if you are putting some element here, it's like this, okay, this is A and this is B. If you are putting some element here, if you are putting this element here, then automatically you have to put it here. If you are putting this element here, if you are putting this element here, then automatically you have to put it here. So like this. So what I can say, that every element has how many choices? So this has total n elements, A1, A2, A3. Okay, for each element, how many choices you have? For each element. So you can notice A, B, for any element X, what are the choices? So I can say for any X belonging to X. So these are the choices. It is not in both of them. This is fine. It is not in both of them. Correct? It is not present in any of them. Yes or no? Anmol, I am taking a lot of questions on the same template. Okay. I am taking a lot of questions on the same template I am taking. Okay. So just focus here. So you can notice, you can notice here. So for any element, because read the question very carefully. X has n elements. So this set X has n elements. This is your set X in which you have total n elements. Okay. So X has n elements. How many pairs A comma B are there? We want these pairs A comma B such that A should be subset of B. A should be subset of B. For example, I can say that maybe A is this. Okay. For example, A is this and B is this. This is fine. There is no problem here. 1, 2, 3, 4. Okay, so this is fine because you can notice A is subset of B. Okay, so this is the point. So now you can notice that in set we have total n elements and we want these type of pairs A comma B. These type of pairs we want where A must be a subset of B. What it means? It means that if some element is here, then automatically it should be here. What it means? It means that if some element is in A, then it's definitely should be in B. Okay, if it is in A, then it should definitely be in B. For example, here, if it is in A, then it should definitely be in B. But you can notice that some elements, they can be in B but not in A. So some elements can be in B but not in A. So these situations are fine. These situations are fine, but you can notice this is not fine. This is not fine. Why? Why this is not fine? Because you can notice if you have this type of situation, let's assume that A is this 1, 3, and let's assume B is this 3, 4, then you can notice A is not a subset of B. So finally, I can say that A is a subset of B if, okay, I can say A is a subset of B and both are subset of some S. Okay, A is subset of B and both are subset of S if and only if for all X belonging to S, for every element belonging to S, what should happen? If it belongs to A, then it should definitely belong to B. Yes, correct. If it belongs to A, then it should definitely belong to B. Then we can say that A is subset of B. So here I can say that every element has 3 choices. For every element, we have 3 choices. So that's it. So finally, answer will be what? Answer will be 3 power n because every element has 3 choices. Yes or no? So here finally, I can say that in this A1, A2, A3, and so on An, you can notice that this element has 3 choices. What are the 3 choices? So let me just write it. This element has 3 choices. What are the 3 choices? Let me tell you that it can belong to A, also it can belong to B. It can belong to B, but it does not belong to A. It does not belong to both of them. So these are the 3 choices. and every element has these three choices. So final answer will be what? So what is the answer? Because every element has three choices, so finally you can say 3 power n ways, 3 power n pairs. Okay, this is GATE 2021 question. Can you try this? Yes, in that question also you can do. If A and B are non-empty, then answer will be 2 power n. No, Sandeep, then answer will be 3 power n minus 1. Okay, sorry. If both are non-empty, then what will be the answer? See, if both are non-empty, okay, let's do this variation. Okay, everyone, kindly do this variation. So Sandeep is asking this question. Okay, so let's do this variation. Basically, you have a set S X in which you have cardinality n, and basically you have A is a subset of B, B is a subset. Okay, so these are subset of X. A comma B are non-empty. A comma B are non-empty. They must be non-empty, both of them. A must be non-empty, B must be non-empty. Then tell me how many pairs. Tell me how many A comma B pairs will be there. Tell me. Now tell me how many pairs must be there. Try this. So what is the answer? See, okay, let me try. So first of all, why 2 power n is wrong? Let me tell you. Okay, why 2 power n is wrong? So, okay, is this a correct? C? A comma B must be non-empty. Okay, so first of all, is this the correct solution? Okay, just tell me this point. Okay, just tell me this point. You have X which have A1, A2, A3, and so on, AN. And now I am saying that, is this a correct solution that these are the two choices? Okay, it is here also, and it is not here, but it is here. Are these the only valid moves? Okay, can I say that these are valid? Can I say for each element I am saying, can I say for each, can I say for each AI belonging to X, can I say that these are valid and these are invalid? Can I say? See, this is wrong. Why this is wrong? Why this is wrong? Because see, this is wrong. What is the reason? Of course, the reason is, first of all, from this you can notice that every element has some restriction here. What is the restriction? Can anyone tell me? Okay, can anyone tell me if this is the answer, if this is the answer, then what will be B? Just tell me at this point. Why this is wrong? If this, okay, then what will be B? If this is your answer, then what will be B? Then B will be X. Yes, that's the mistake. Why? Why this is wrong? Because you can note that B is equal to not, because now B is equal to X. Now there is no choice for B. Now B has to be X. because you can notice for every element you are saying that it has to be in B. For every element you are saying that it has to be in B. So can you notice this is wrong? Okay. Another mistake is here A can be empty. Another mistake. So this is mistake number 1. Okay. This is the mistake number 1, because here A can be empty, but we are saying A should not be empty. Here A can be empty. For every element, if it is not present in A and every element is present in B, that is also that case is also counted here. Anyway, the point is this, that this is not the correct answer. So what is the correct answer? So the correct answer is this. Again, desired cases minus undesired cases, total cases minus, again I told you what are the desired cases, that is equal to total minus undesired. Okay, so what are the total cases that we have already seen? Total cases are 3 power n. Undesired cases, undesired means from these 3 power n cases, remove when either A or B is empty. Yes or no? Remove either A or B is empty. Okay, so basically from these cases you remove when A is empty or B is empty. Just remove it. How many cases we have to remove? Can anyone tell me? See, if B is empty, then automatically A is empty. But if A is empty, okay, if B is empty, then automatically A is empty. But if A is empty, then how many? Then B can be anything. Yes or no? B can be anything now. So for B we have, for B, how many choices we have for B? 2 power n minus 1 choices. This can be any subset actually. This can be any subset other than 5. Other than 5. So total undesired cases is equal to 2 power n. Total undesired cases is equal to 2 power n. Yes or no? Anyone has any doubt in this? So total undesired cases are 2 power n. So final answer will be 3 power n minus 2 power n. Okay, so the desired cases will be 3 power n minus 2 power n. How many got it? Is there anyone who got this answer? Anyone who got this answer? See, okay. See, we want, okay, in the original problem, you can notice, okay, first of all, the original problem, A can be empty, B can be empty. Okay, so this is the original problem. You understood the original problem answer, right? Yes or no? X has cardinality n. Okay, A is subset of B, B is subset of X. Then A comma B pairs. How many A comma B pairs can be there? Number of A comma B pairs, that will be 3 power n. This is clear to everyone, because every element has 3 choices. Okay, because every element has 3 choices, we can say that answer is 3 power n. Now the problem is that A should not be empty, B should not be empty. Now, okay, A comma B both are non-empty. Means we cannot allow empty. Both are non-empty. So these type of situations are disallowed. So we have to remove. So remove. So I can say so remove. So basically we have to remove them. Okay. For example, this we have to remove. For example, this we have to remove. Yes or no? For example, this we have to remove. Okay. For example, like this. Yes or no? So all these cases we have to remove basically. Okay. All these cases. So remove them. Remove these undesired cases. These are the undesired cases. Okay, so how many these undesired cases are there? Can anyone tell me? How many? So in these 3 power n, These are the undesired cases. Remove these undesired cases from 3 power n. From these 3 power n, from 3 power n. So from these 3 power n, just remove these. How many are there here? 2 power n total. Total 2 power n. How many are here? Total 2 power n. So these are total 2 power n cases. Total 2 power n pairs. These are total 2 power n pairs. Because this A is 5 and everything else you can notice. So these are total 2 power n pairs. These I am removing it. Okay, so the answer is 3 power n minus 2 power n. Is this clear to everyone? Anyone has any doubt? So like this, you can create variation basically. Okay, in GATE exam is all about variations. See, if you by heart the concept, it is not going to help you in the GATE exam. GATE exam is all about variations. They will ask you, next year they will ask you the same question and they will say that A comma B should be non-empty. Then the answer will be 3 power n minus 2 power n. So GATE exam is all about these type of small variations. Okay, they will change a little small information they will change. You should handle it. So that is the reason, just understand the concept, just focus on understanding the concept. Okay, once you understand it, you will never forget it. Okay, so anyway, so this is a GATE 2020, this is 2021 question. Can anyone tell me what is the answer? Can you check in all these questions, we have individual choices for each element. So this is the same question that we have done now. Okay, this is the same question, answer is to 3 power n. Okay, can I create some variation? Can I give you some variation? For example, try this variation. Anyone? Try these variations. What is the answer here? Okay, so let me just remove the answer. You tell me the answer for these variations. So can you try them? All these variations, can you try? Okay, the answers are already here. Okay, so I've also written the answer here. So you can try all these variations. Okay, so if you want, can I give you this as a homework? You can take it as a homework and the answers are already present here. You can notice. Should I do any one of them? I can do any one of them I can do. Okay, tell me which one should I do? One of them I will try. So, okay, so let me do second one. Okay, so you notice the second one is saying that find the number of ordered triples A, B, C where A, comma C both are subset of B. Okay, so you can try this. Okay, so let me try the variation 2. Let me give you the answer for variation 2. So basically variation 2 is like this. Okay, so basically you have a set X again which has n elements A1, A2 and so on an. Okay, so these are the n elements. Now the question is that we want, okay, how many pairs? So the question is saying how many pairs, how many ordered triples, how many ordered triples? Okay, A, B, C, this type of triples, this type of ordered triples, this question is wanting. Yes, this annotated PPT will be provided on the Go Classes platform. Okay, so when you go to Go Classes on the website, you will find this. Okay, so Go Classes. Okay, then you basically sign up. Okay, free. This sign up is basically free. Okay, and then you go to the revision course. Okay, so here you can find all the this whole revision course. The revision course is available here. Okay, so let's see this. Okay, so how many ordered triples are there? A, B, C. Okay, and the condition is this, that this you can notice this A, B. Okay, so A is a subset of B and also C is a subset of B. Basically A comma C, basically this and this, they are subset of B. So this is the condition basically. Okay, so you can notice A is the subset of B and you can notice C is also the subset of B. A comma C both are subset of B. Now tell me, for each element how many choices we have? Just tell me this point. Okay, for each element element X belonging to X, how many choices we have? A, B, C. or let me write it like this: A B C, or okay, A B C. So how many choices I have? You can notice that. You can notice A must be subset of B. First of all, A must be subset of B. Also, C must be subset of B. These two conditions must be satisfied. So tell me, this is okay. This is fine. So you can notice this is fine. Yes. So okay, means X is present here. X is present here. X is present here. X is present here. This is fine. Correct. So this is fine. X is present in A. X belongs to A. X belongs to B. X belongs to C. This is fine. Okay. Is this fine? Tell me. Okay, so let's go one by one. Is this fine? Tell me. Is this fine? Yes, this is fine. Is this fine? Just tell me this point. Is this fine? This is not fine because now C is not a subset of B. Is this fine? Yes. Is this fine? Yes. Is this fine? No. Is this fine? No. Is this fine? Yes. Okay. So like this you can do. Okay. So finally one. Okay, this is also fine. So you can notice how many choices I have. For each element, 5 choices I have. Yes or no? For each element total, 5 choices we have. For each element. Okay, so like this you can do. So finally answer will be what? For each element you have 5 choices. Okay, so 5 choices each element. Okay, so finally answer will be 5 power n. Okay, so that's the reason. Answer 5 power n, because total n elements are there and each element has 5 choices. This element 5 choices, this element 5 choices, this element 5 choices, because total n elements we have. So that is the reason 5 power n. These many ordered triples will be created. Okay, so you can try all these variations. The answers are already present. Okay, can you do this? So when you understand the concept, then everything becomes very easy. Okay, just don't buy hard. Okay, don't buy hard formula. Don't in the gate exam, this is not going to help you. Okay, whatever you do with complete analysis. See, knowing the answer of gate question is not enough. Can you notice here? Can you notice here in this question? Can you notice that many students know the answer of this question, that is this 3 power n? Many students know. Okay, you can find in the market, you can find a lot of students know the answer of this question, that it is 3 power n. But if you create a small variation like this type of variation, if you create, then how many students will be able to do? This is the question. Okay, so you should be in those students who understand the concept very clearly, that you can handle any variation, any small variation, big variation, whatever variation they give you, you should be able to handle. Okay, so just focus on understanding the concept. Okay, solving the question is not enough. You should solve it thoroughly. Okay, with complete analysis. Okay, so let's see this. This is another variety of question that I want to talk about. Okay, this is called grid problem. Okay, so let me just teach you this concept. This is something called grid problem. Okay, some people call it grid problem. Okay, some people call it, for example, in ISC we call it north, okay, highway problem basically. Okay, highway problem. Okay, anyway, so in ISC we call this highway problem, but on internet some people call it grid problem, whatever. Okay, the name does not matter. Basically the point is this. For example, if you have this, let's assume this is your highway, or this is a grid. Okay, maybe this is a highway. Okay, and you can notice that okay, so maybe this is a grid or something. Okay, now let us assume that you are here. Okay, so you are here, and from here you want to go here. Okay, at this point you want to go. Okay, so let me do this. Okay, so you want to go here. Then how many ways are there basically? And the condition is there. What is the condition? You can go one step up, or you can go one step right. So basically this is the, okay, like you cannot go left. For example, if you are here, you cannot go left, you cannot go down. So this is the point. Okay, in every step you either can go up or you can go left, right. Okay, so in every step, I can say, in every step, either go left, either go right or up. by one step. Okay, so this is one step. So I can say this is one step. So tell me, in this question, can anyone tell me how should I do? What is the answer? Why 8C4? The question that I want to ask is why 8C4? 7C4, 7C3. Why is that? Can anyone give me the logic? I don't want answer. Again, see, knowing the answer is not enough in the GATE exam. Many people know the answer, but why? Why is the question? Why? Can anyone tell me why is the okay? Many people are saying answer is 7C4, but why? How can we guarantee that only see? Okay, let me tell you. Say, okay, first of all, this is the question. Okay, means how many ways are there to go from here to here? For example, this is way. Okay, for example, this is way one. I can say I can go like this. I can go like this. Okay, what I can do? I can go like this. Then I can go like this. Then I can go like this, and then I can go like this, and then I can go like this. This is it. This is, I can say, this is path one. This is path one. Okay, another path I can take is maybe this. Okay, for example, another path I can take is this. I can go like this, like this, like this, like this. Okay, so this is your path 2. So you can notice like this. So how many paths are possible? The point is this. Okay, so number of paths that are possible means number of ways you can go from here to here. Okay, so now let's see this. What is the answer here? See here, one thing you should note is that, okay, we can prove something here. Some very nice point we are going to prove here. Okay, see, let me tell you that if you are going here from this point, if you are going here, then how many right move you have to make? Okay, whatever path you take. For example, if you take this path 2, then this path 2, I can say that you have taken up, okay, right, up, right. Okay, so this is your path 2, means up, right, up, right. Okay, so this is your path 2. And what is path 1? Path 1 is right, up, path 1 is right, up, right, up, right. Yes or no? So I can say path 1 is this one, right, up, right, up, right. Okay, and this is your path 2. So similarly, I can say that whatever path you take, I am saying that whatever path you take, for that path, how many this type of sequences you will get? How many you are basically how many sequences you can get? Tell me. Is it possible that you can get multiple sequences for the same path? Is it possible? Tell me. Is it possible that for the same path you can get more than one sequences like this? It is never possible, right? Whatever path you take, for every path you will get exactly one sequence of u comma r, I can say. Okay, so this is the first observation. So you can notice the observation 1. What is that? For every path, for every path, I can say from initial to final, this is your initial, this is your final. Okay, from I to F, I can say for every path exactly one, I can say, okay, exactly one sequence of u comma r of how much length? Okay, so you can notice that exactly one sequence of u comma r we will get. Exactly one sequence we will get. We will not get more than one. We will get, okay, for every path, whatever path you take. For example, if you take this path, then what this means? This means right, up, right. Okay, so for every path, what you are going to get? Exactly one sequence of u comma r we will get. Okay, and this sequence we will have in this sequence, basically you will have how many? You will have 4 right and 3 up. Basically, you will have 4 r's and you will have 3 u's in this sequence. Okay, so this is the first observation. This is the observation number 1. And what is the second observation? Observation number 2. What is that? That is that if I give you a sequence, okay, for any sequence, I am saying, okay, for any sequence, if I give you a sequence for any sequence of 4 r's comma 3 u's, This is the observation that we can make. For any sequence, whatever sequence you take of 4 R's and 3 U's, we will get a path from I to F. Yes or no? Is this true? We will get a path. We will get exactly one path from I to U. We will get exactly one path from I to U. Because whatever sequence you take, if you take any sequence, that is your choice. Okay, if you take this sequence U R, then you will get a path. Okay, so for this sequence you are getting a path. For this sequence, this is the path. You can notice like this. Okay, like this you are getting a path. Okay, this is your I, this is your F. So whatever sequence you took, U R. Okay, U R. So for this sequence also, you will get a path. Okay, U R. So you can notice, okay, 1, 2, 3. Okay, yes, correct. So you can notice that you are getting a path. So this is the point. So finally, from these two observations, what we can, okay, so I can say this is the point. Okay, so this is the observation that this is your path from I to U. This is your path from I to F. Okay, and this is your sequence. This is your sequence of 4 R's, 3 U's. Okay, so finally I can say that there is one-to-one correspondence. There is bijection between them. Yes or no? There is bijection between them. If you have a path P1, then there is a one-to-one. There is exactly one image here. For every path, you have exactly one sequence here. You have exactly one sequence here. Okay. Similarly, you can notice for every path exactly one. Okay. So there is a, and similarly, if you have a sequence here, R, U, okay, R, U, R. Okay. So you can notice if you have, then again exactly one path you will get. Do you agree or not? So this is from these two observations, this is what we can see. So I can say there is a bijection. There is a bijection between them. So number of path is equal to number of sequences. Yes or no? So there is a bijection. Agree or not? Because for every path you have unique image here, and for every sequence you have unique path. Yes or no? For any sequence you have unique path, and for every path you have unique sequence. So what I can say, tell me. Can anyone tell me what I can say? So there is bijection. So there exists a bijection between what? Between number of paths from between set of paths, I can say. Okay, between. So there exists a bijection between set of paths from I to F and set of sequences of 4 rights, 3 ups. So finally I can say, and when you have bijection, then what happens? Can anyone tell me? If there exists a bijection between set A and set B, then what happens? Tell me. If there exists a bijection between set A and set B, if there exists a bijection between set A comma set B, then there exists a bijection between set A and set B if and only if their cardinality is same. If and only if their cardinality is same. Their cardinality must be same. Okay, so there exists a bijection between set A and set B if and only if their cardinality is same. So here the cardinality must be same. So I can say number of path is equal to number of sequences of 4 R's and 4 U's. So finally, how many sequences are there? Just count it. So finally, this is the final conclusion. Number of paths from I to F. This is equal to number of sequences of 4 R's, 3 U's. Yes or no? 4 R's right and 3 up. Okay, so that's it. So this we can very easily calculate. Yes or no? Actually, this is our target. The question is asking this. Now to find this, we can very easily calculate this. And what is this? Can anyone tell me? 4 R's, 3 U's. So this is 7 factorial divided by 4 factorial, 3 factorial. Yes or no? How many sequences are there in which you have 4 R's and 3 U's? Can anyone tell me? Can anyone tell me how many sequences of 4 writes and 3 U's? How many sequences are there? Basically, it's like R, U, U, U. How many permutations? Number of permutations. What is that? Means how many sequences? Means number of permutations. That is 7 factorial divided by 4 factorial, 3 factorial. How can I prove it? See, okay, very easily you can get it actually, because all you have to do 4 R's, 3 U's. Okay, so what you can do? What you can do is just select positions. You have total 7 positions. See, you have total 7 positions. 3, 4, 5, 6. Okay, you have total 7 positions. From 7 positions, select 4 positions for R. You have total 7 positions. Select 4 for R. Let us assume I select this, I select this, I select this, I select this. Now, automatically in the remaining position, you will go. Automatically in the remaining position, you will go. Okay, so from the 7 position, select 4 position for R. Automatically in the remaining position, you will go. Or from the 7 position, select 3 position for U. Automatically in the remaining position, R will go. Okay, so that's the point. So answer will be 7C3. Okay, so this is the answer, 7C3. Is this clear to everyone? This problem, this grid problem, this highway problem, is this clear? This observation is clear or not? That there is a bijection between this proof. This is the proof, remember. And if you know the proof, then you can handle any type of question. If they give you some variation, I don't know what they will give you. The GATE exam, they can give you anything. We don't know. But if you know the proof, then definitely you can handle it, because you know why it is coming. Now you know why this formula is coming. Okay, so like this you can just very easily do. Okay, so you can just try this this variation, you can try. So if you have, tell me, let us assume you have this type of grid you have. Okay, just tell me what is the answer. Okay, I want to go. Okay, so like this you have. So let's assume like this you have. Okay, just tell me what is the answer. Okay, and from this point you want to go, from this point you want to go to this point, and you can only go up or right, basically. Okay, the only move, okay, either move right or up, either move right or up. Then tell me how many ways are there? Either move right or up by one step. Then tell me how many, what is the answer? So here, what is the answer? Very simple. First of all, you can only move right or up. Okay, so you can never go here. At this point, you can never go. You can never go, because if you go here, you can never go here, because you can only move right or up. Okay, so once you go here, you can never go here. So finally, answer will be what? Okay, so how many horizontal moves you have to make? 1, 2, 3, 4. 4 horizontal moves and 3 vertical moves. 4 horizontal, 3 vertical moves you have to make. Okay, so finally I can say 4 right moves, or I can say horizontal moves. 4 right moves you have to make, and 3 up moves you have to make. Okay, now so finally answer will be 7C3. Okay, so this is the answer. Like this you can do. So can you try this question? This is GATE 2007 question. Suppose that a robot is placed on a Cartesian plane. Okay, at each step it is allowed to move either 1 unit up or 1 unit right. If it is at ij, then it can move to I plus 1j or ij plus 1. How many paths are there? Distinct paths are there. Okay, so there for robot to reach the point 10 10, starting from the first initial position. Okay, so here what is the answer? The answer is quite very simple, that basically you have this Cartesian plane. Okay, on this Cartesian plane from 0 0, from this you want to go to 10 10. Okay, so this is your 10 10. You want to go to 10 10 from 0 0. Okay, And you can notice at each step you can basically go either up or you can go right. Okay, at each step, for example, this is 0, 1. Okay, sorry, this is actually this is x. If this is the x-axis, okay, if this is your x coordinate, if this is your y coordinate, then this is basically 1, 0, like this. Okay, and this is basically 0, 1. If this is your x coordinate, this is your y coordinate, then it is like this, something like this. Okay, anyway, so finally what I want to say is how many horizontal move, how many right moves you have to make, and how many up moves you have to make. Just tell me this, that one. Okay, so you can notice that total 10 horizontal, 10 right moves you have to make. Okay, so here, from here you want to go here, so 10 right moves you have to make and 10 up moves you have to make. So finally our answer will be what? 20C10. Why 20C10? Because see, remember 10. Okay, so total 20 position you have. Okay, there are total 20 positions. There are total 20 positions you have. From these 20 positions, you can select 10 position for R. Automatically in the remaining 10 position you will go. Okay, so like this you can say answer will be 20C10. Answer will be option A. Can you try this question? This is small variation. This is small variation. The question is saying that basically the robot cannot traverse in the line segment 44 to 54. This is okay. Let's just finish this question and then we will take a break. Just tell me this question. Okay, just answer this question, then we will take a break. Tell me. So the robot cannot go from 44 to 54. Robot is not allowed to traverse the line segment from 44 to 54. Okay, so there is a 44 here. Let's assume there is a, this is 44. So there is a 54 here. So you can notice this is 54. Okay, and this is your 0, 0, and this is 10, 10. Okay, so basically you cannot go here. I can say this is broken. This is broken. Okay, so you cannot go here. So okay, you cannot go here. With this, what is the answer? You cannot go here. Remember, you cannot go here. So again, the answer is very simple, because you cannot go here. And in India, what happens? Actually, not in India, in world, in the whole world, it happens that if someone tells you to not do something, then you will do it. Okay, so do that. Okay, basically that is the rule. The robot should not go here, so just go here. Okay, so that's the point. Just go here. Means basically total case, desirable cases. Finally, I can say that desirable cases is equal to total cases minus undesirable cases. Okay, so what are the total cases? This we have already seen, right? So this is 20C10. This is the total cases. Undesirable means go to basically take this. Basically take this 4454 line. Take this line. Okay, so if you are taking this line, then what it means? If you are taking this line, then what it means? See, if you are taking this line, it simply means that you are going at 44. So first you are, okay, somehow you are going here. Okay, so how many ways to do this? How many ways to do this? 4. So this will be 8C4. And then you are taking this, and then you are going here. How many ways to do this? Tell me. So you can notice 5 right moves you have to make, 6 up moves you have to make. So that means basically 10C, 5 right moves you have to make. Okay, 6. So that means basically 11C5. Okay, so this means 11C5. I can say this means 11C5. So finally you have to multiply them, because you have to do this, you have to do this, you have to do this. These 3 things you have to do. So finally answer will be okay. So here answer is going to be, okay, undesirable cases 20C10 minus, that will be 8C4 multiplied by 11C5. Okay, so this is the answer. Okay, so like this you can do this question, and this is a popular problem. Remember, this is a popular template. Okay, how 8C4. See, if you if you want to take this line, then what you have to do? Just tell me this point. If you want to take this line, then you have to go to 4, 4, right? First, you have to go to 4, 4. First, you have to go here. First, you definitely have to go here. There is no other way. You have to go here. Then you have to take it. And then you have to go to 10, 10. From 0, 0 to 4, 4, how many paths are there? From 0, 0 to 4, 4, how many paths are there? That is because from 0, okay, here you have to make 4 right moves you have to make, and 4 up moves you have to make. Yes or no? So, ma'am, is this clear? You have to make 4 right moves and you have to make 4 up moves. So that is the reason 4 right moves, 4 up moves. So that is the reason 8C4. Why 8C4? Because 4 are for you. So total 8 positions are there. From 8 positions, you select 4 position 4, because 5 right moves and 6 up moves. Ananya, see, from here you want to go here. What it means, you have to make 5 right moves and you have to make 6 up moves. 6 step upward and 5 step to the right. So that is the reason. Okay, 11C5. Okay, is this clear to everyone? So we will take a break, but this is the last question on the grid problem. This is a standard university problem. Okay, so here you have 2 more variations basically. Okay, some more variations you will find here. So can anyone tell me the answer now? Okay, some more variations are there, are present. Find how many different routes are there without restriction. How many routes are there without restriction from A to B? And you can notice you can only go either downward or you can go to right. Okay, so either you can notice either you can go to downward or you can go to right. Okay, so this is a popular problem. Remember this grid problem. This is a very popular problem, very popular combinatorics problem. Okay, so what is the answer for option 1? So you can notice 1, 2, 3, 4, 5. So this is actually 6 by 4. Yes. So this is basically 6 by 4. 6 down moves you have to make. 4 up moves you have to make. So you can notice 6 down moves. Okay. 6 down moves you have to make, and 4 right moves you have to make. Okay. So total 6 down moves. I can say down moves means 6 down moves you have to make. Okay. And 4 right moves you have to make. So total how many permutations are there? Means in any order you can make, because in whatever order you make, you will go to from A, you will go to B. Okay. So how many permutations are there? So the answer is 10C4, because total 10 positions you have. So I can say total 10 positions you have. From these 10 positions, you select 4 positions for R. I can say select 4 positions for R. Okay. So select 4 positions for R. That means 10C4. In the remaining position, automatically D will be there. Okay, so this is the 10C4 for this. What is the second? If you must pass through C, you must go through C. Okay, this point, you must go through this point. So then the answer is very simple. If you have to go through this C, then for the second problem, so what you have to do? From A, you have to go to C. From A, you have to go to C. Okay, and then from C, you have to go to B. Okay, so this second problem, from A, you have to go to C, and from C, you have to go to B. Now, from A to B, you can notice 2, 2. Okay, 2, 2. So basically, if you want to go here, then you have to do 2 right moves and 2 down moves you have to make. And here, how many? So 2 right moves and 4 down moves. Here, 2 right moves and 4 down moves you have to make. Okay, so you can notice here how many ways you have. So 4C2 ways you have here. Now once you are here, then how many ways you have here? 6C2 ways you have here. Okay, so finally I can say then answer will be 4C2 multiplied by 6C. Okay, so this will be the answer. 4C2 into 6C2. What is the answer for option for statement is 3 for the question number 3? If you cannot move on the top line, basically this line you cannot move. Okay, don't go, basically don't go here. This line you cannot go. What it means, can anyone tell me? If you cannot go here, what it means? It means the first move has to be down move. The first move has to be down move, yes or no? So the first move has to be down move, yes or no? First move has to be down move. Okay, so basically you have to start with the down move. Once you are down, once you are here, now the question is very simple, A to B. So, okay, once you are here, then the answer is very simple. What is that? 9C4. Okay, so basically 9C4. This is the answer. Okay, because you cannot, first move has to be down move. Okay, then I can say that 5 down moves you need. Okay, then 5 down. Okay, and 4 right moves you. So that will be 9C4. Okay, what is the answer for the for the fourth? If you cannot go in this line, don't go in this line. Basically, in this fourth option, this line is prohibited. Now, what is the answer? You cannot go on this line. So, for the fourth question, you cannot go in this line. Here you can create cases actually. Okay, see, you can create the cases. What are the cases you can create? So you can create cases here. If your first move is down move, see, either, okay, basically here you can create the cases. What are the cases you can create? Tell me. Case 1. What is the case 1? You start with the down move. If your first move is down move, then what should be your second move? Can anyone tell me? If your first move is down move, then what should be your second move? It has to be down. It has to be down. There is no other choice. Okay, so you can notice if your first move is down, then automatically it has to be down. Now the remaining. Okay, what is the remaining? The remaining, okay, once you are here, then basically this is just a 4-4, means basically this is 8C4. Okay, so in this case 1, basically you have 8C4. What is the case 2? Case 2 is you make right move, then you make down move. Okay, you make right move, and then you make down move. Then what should be your next move? Can anyone tell me? If I make right move, then I make down move, then the next move has to be down again. It has to be down. Now what is the answer? Now the answer is 7C4, I think. Yes or no? Now the answer is 7C4. Now case 3. What is that? You make right move, then you make right move, then you make down move. Now it has to be down. Now it has to be down. Okay. In this situation, what is the answer? Right move, you make, then down move you make. Now it has to be down. Okay. And finally, right, down, it has to be down. Here you have only one way. Okay. Here how many ways? Right, down. Okay. Right, down. Here. Okay. So that will be 5C. What is that? 5C1. 5 ways. Okay. So that is 5C1. Is this correct or not? Is there any doubt? Here it should be RR D. So basically this should be 6C2. Okay, I think 6C2. Okay, so you can make it 8C4, 7C3, 6C2, 5C1, and then 4C0. Okay, so this is your answer. Just add all of them. That is your answer. Yes or no? Is this clear? Is this question clear to everyone? So this is just another variation. Okay, anyway, you can handle all these type of questions. Okay, after the break, we will take the recurrence relation based questions. Okay, a lot of questions I am going to take after the break. This is a recurrence relation based question. This is another recurrence relation based question. And then this is another recurrence relation based question. Okay, so a lot of this is recurrence relation, this is recurrence relation. So a lot of questions which are recurrence based relation I will take. And similarly, we will also see derangement recurrence relation. How to write the recurrence relation for the derangement problem. Okay, because we can write the recurrence relation for many combinatorics problem, and we will see how to write the recurrence relation for derangement problem. Okay, so this is your, this we will see after the break. Okay, so okay, anyway, anyone has any doubt right now? Anyone has any doubt right now? Is this class helping you? Is like, can anyone tell me? Is this session helping you? See, I'm not. I'm not going to waste your time by self promotion or something. Okay, so we started at 6 p.m. and from then onwards, continuously we are studying. Okay, basically we did not see like, okay, I hope I did not waste your time because self promotion and all these things and all these things. Okay, so continuously we are studying, and this is what we are going to do in our revision course. Okay, so from today till gate exam, we are going to meet every day. Okay, in the live class we are going to meet. Okay, and every day we are going to do just study basically. Okay, just we are studying together. Okay, it's like that. Okay, so for 4 or 5 hours we will study together. Okay, if anyone is interested, you can basically join. Okay, there will be some very nice classes like decidability class. Okay, there will be one lecture on decidability, 4 or 5 hours. I will teach you decidability, and we will solve each and every gate question. And there is a PDF, there is a university PDF in which there are 53 questions. Those 53 questions, all of them I will solve in the class. Okay, so there will be a 5 or maybe 4 or 5 hour session for decidability. Okay, so I think on 18th you can just check the schedule. Okay, so like that. Anyway, so let's meet after some time. Okay, so don't waste your time and study. Okay, utilize every minute because gate exam is coming. Okay, and you should utilize every single minute. Okay, yes, Debachran, we will take. Okay, we will take the decidability class. Okay, so let's take a break for maybe half an hour. Okay, dinner break, you can take a dinner break, and after the break we will meet again. Okay, so I will create a new session. I will create a new. Okay, new link will be shared in the group. Okay, in the Gate Overflow group and Go Classes group, a new link will be shared. You can join that group. Okay, that link. Okay, this session I am terminating. Okay. Okay, so basically we will start at 9. We will start at 9:30. Okay, a new link will be shared. Okay, so now I am terminating this lecture. New link I will share, and at 9:30 we will start again. Okay, thank you everyone.